Good afternoon. I want to welcome you to Decarbonization 101, an introduction to better use of energy in buildings webinar. Thank you all for attending. Presenting today will be Michael Goodrum, who's the Technical Director of Existing Buildings Policy at NORESCO. NORESCO is part of a team that's been working with NYSERDA and the Department of State, providing technical support for projects seeking to decarbonize existing buildings and new construction. And with that, I'll go ahead and turn it over to Michael.
Thanks, Susan. And yeah, like Susan said, Michael Goodrum with NORESCO, we do energy and sustainability retrofits for all sorts of buildings, as well as other sustainability consulting. And today we are going to give an overview of building decarbonization, and we will start with the what and why behind decarbonization and building decarbonization specifically, talk about the path for getting there, and then we'll review a variety of strategies for building decarbonization and some basic costing. And then at the end, we'll talk about some specific details for decarbonization compliance within the New York Downtown Revitalization Initiative and New York Forward programs offered by the Department of State. Some key terms as we start through. So I think some of these will be familiar with to folks, but we'll go through them quickly here. Gases that trap heat in the atmosphere are greenhouse gases, which leads us to decarbonization, and really that's just reduction of carbon emissions. When we start thinking about building decarbonization, that's focusing in on reducing carbon emissions through reducing the building energy demand and energy load, as well as converting systems to more efficient and especially away from fossil fuel combustion processes, which leads us to building electrification, which is specifically the shift from fossil fuels to for heating and cooling to using electricity. Another piece of building decarbonization is embodied carbon, and that's looking at the greenhouse gas emissions that are associated with essentially all the other aspects of the life of a building material beyond its operating for its use in the building. And we ultimately, with building decarbonization, are looking at achieving carbon neutral buildings where the design, construction, and operation of the building do not contribute to greenhouse gas emissions. And a last one that comes kind of hand in hand with decarbonization is the idea of resiliency, and a resilient building, which is a building that's designed to help protect the health and safety and comfort of the people in the building from different stresses, whether it's like power outages, weather events, extreme temperatures, things like that. Some background on building decarbonization for New York. New York has the Climate Act, and primary goal of New York's Climate Act is to reduce carbon emissions by 85% by 2050. You can see in the infographic on the left that buildings in particular, and buildings and transportation, make up more than half of the greenhouse gas emissions for the state of New York. And with over 6 million buildings in New York, they are the largest portion. And for decarbonization, as within the DRI and NYF programs, we're focusing in on decarbonization of buildings. Some of the benefits of decarbonization, there's a variety of them. One, it can help to safeguard against changing fuel prices, especially for fossil fuels, that may become more expensive over time. It can maximize square footage in a building or usable square footage, being able to mount heat pumps like in walls or ceilings, gets them off the floor where you might have had equipment before. There are health benefits from, all electric appliances or eliminating fossil fuel combustion indoors that help with reducing indoor air pollutants and, provide better indoor air quality for occupants. Increased resilience. We were just talking about, the definition of a resilient building and, being able to keep power on and keep buildings comfortable even during extreme events. As well, occupant comfort, we kind of touched on health benefits and resilience there. Those, contribute to occupant comfort and just a lot of times we can increase airflow and air movement, which helps as well. And safety as well, with reduced risks from, like old gas infrastructure that might have leaks or things that can be a hazard, to, things like electric appliances like induction cooktops that reduce your chances of burns and fire. How do we get to decarbonization? That and within these DRI and NYF programs, we're looking at new and existing buildings and transportation as well. Like I mentioned, we're kind of focused on building decarbonization here, but there are transportation benefits that can come with some of the building changes. So new buildings wanting to make more efficient designs, looking into building electrification, better envelopes. Another piece is grid interactivity and being more responsive to the grid that helps not just your building and can help with your energy costs, but also helps with a cleaner grid overall. And then including clean energy sources for your building. Existing buildings are similar. In the case of existing buildings, it's really retrofitting the old systems with new that are more efficient, that are electric, things like that, making upgrades to the envelope, adding clean energy sources. And then, adding, like with the prevalence of electric vehicles now and other alternative fuel vehicles, adding place for those in buildings can contribute as well. And, with these programs that the Department of State offers, many of them are helping to bring back to life downtown areas, make them more walkable, and can help reduce miles driven and things like that. Thinking more specifically toward buildings, considerations for new or existing buildings, thinking about decarbonization, a big piece for new buildings is integrated design and making sure that the various stakeholders are all involved early on and understand the goals for decarbonization and can talk through various strategies. We've got some listed here, and what's needed in the design to achieve those. By doing it early and getting, all of the stakeholders engaged at the beginning, it can help, one, streamline the process, but also can reduce costs so that, you don't have rework or changes in design later because something wasn't accounted for in meeting certain decarbonization goals. For existing buildings, constructability and just thinking about the fact that you're backfitting into existing systems and spaces. You've got occupants in the building that you're trying not to disrupt. And so, coming up with ways that you can make sure that, the building is still maintained for occupants, that, equipment fits, that it's not going to lead to other, changes and issues that you might run into, and just doing your due diligence up front so that you're prepared for contingencies and things like that. Now we'll talk about a decarbonization path. And, we've got this numbered 1 through 7. And, it's a framework to think about, stepping through decarbonization for a building. At the same time, these aren't done only in series, right? They, a lot of these can be sort of done in parallel and combined. But as we are thinking about decarbonizing a building, we started looking to reduce energy loads And that helps us both with electric loads and heating and cooling loads. And that can come through maximizing energy efficiency of systems to be able to achieve the same results using less power. Then starting to layer in building electrification strategies where you're moving to things like heat pumps and stuff like that, away from what may have been fossil fuel burning systems before. And then adding in building automation and building control systems for both mechanical equipment and lighting, and can also include things like plug loads and the like to help turn things off when they don't need to be on or optimize system operation. And then you can incorporate distributed and especially renewable energy, and having clean energy sources on site that can help to produce power for your building and maybe reduce some of the demand on the grid. When that's combined with energy storage systems, that really helps you. Where, say, if you had a PV system, it may produce a lot of power in the middle of the day, but not as much in the evening or at night. And it would allow you to store extra power produced during the daytime and use it later when maybe the PV system is not producing. And last, then embodied carbon, and starting to think about the life cycle carbon of both materials and equipment in the building, whether it's new construction and what's going into it that you're building with, or if you're doing a retrofit, the embodied carbon of what you're taking out, like that's being replaced, and also of the new equipment that's going in. Now we'll talk about a variety of decarbonization strategies. Following the path we just talked about, we'll first talk about various load reduction strategies, and then strategies for building electrification, layering in advanced controls, and finally distributed energy resources for building. Load reduction. When we talk about load, there are two components to think about. The electric load, which is really just how much electricity different systems are using, things that are plugged into a wall, lighting, HVAC, stuff like that. And also heating and cooling loads, which, just how much heating or cooling you need to maintain comfort in your building for occupants or other pieces of equipment. And common strategies that contribute to reducing electric load and or heating and cooling load, high performance envelopes, LED lighting, smart building systems, energy recovery. So we'll go through some different strategies for those. For high performance building envelopes, the building envelope is really all the components that are between conditioned and unconditioned spaces. Typically you can think of it as your exterior walls, windows, doors, insulation, framing, all, even the outside brick, and ways to make those more efficient and better insulated. One is adding insulation and also addressing thermal bridging. You can see in the image there, this structural piece of the building, in the white, and then you have kind of the squiggly lines that are insulation. You can see there's a space where it's not insulated, and you get more heat transfer through that piece. And so bridging that gap with insulation, and there are different strategies to do so, can help reduce heat transfer in and out of your building. Windows, window replacement with more efficient windows, and also thinking about window shading. For New York, with a lot of heating load, when you're starting to think about window replacements and shading, it's thinking about being able to take advantage of sun and heat from outside in the wintertime, but then shading for it in the summer. So doing something like adding films that always reduce the solar heat gain may not benefit you in a climate where you have more heating. Last, weatherization and air sealing, just sealing up the cracks and making sure that the conditioned air inside isn't leaking out, or that the unconditioned air outside isn't coming in, and helping save the energy you've used to make your spaces comfortable. Lighting systems, I think most people are familiar with LED. It's pretty common at this point, but LED lighting is more efficient than previous forms, whether it's fluorescence or even incandescent lighting. And that's, both interior and exterior. I think, some key pieces when we start talking about decarbonization are really adding in the controls to either schedule or use occupancy sensors so that lights are turned off when they're not needed, and taking advantage of daylighting or using things like skylights so that you can either reduce or turn off electric lighting and take advantage of natural light from outdoors, which helps reduce the electric load from your lighting system. Smart building systems, those here we're talking about things that are plugged in, and it's really just systems that are out there that can turn things off when they're not in use. For things like computers, it might mean that it's a system that can leave the computer on, but it turns off like the monitor and the other peripherals when it's not in use, things like that. Each piece adds up and can help to reduce the electric load on the building. And last, energy recovery. And here we're showing a diagram related to largely air ventilation, but it applies, as you can see in the list, even to things like hot water systems. Really, energy recovery is about taking energy from air or water in one place and using it to precondition incoming air or water, and so that can mean that in the heating season that you could take the warm air from inside a building to help heat up the cold air that's coming in. For hot water systems, it may mean that if you have excess hot water that's going out to drain, that there's a way to capture heat from it to heat incoming water. And it's really just about transferring energy you've got that's not getting used to replace using like mechanical means to heat air or water that you're going to use. And the last bullet here, be creative. There's all sorts of buildings with all sorts of systems in them, and there are places where you may generate extra heat or have extra cooling capacity that you could take advantage of to help to condition your spaces. And that way you're using energy that was already, you already spent energy and money on for one application, and not having to, or not just wasting it and having to spend more energy and money to condition your spaces. Moving toward building electrification, like we talked about in the definition before, it's just replacing gas-powered, fossil fuel-powered systems with electric systems, and has a significant impact on reducing greenhouse gas emissions. Especially, New York as a state is working to improve their cleanliness of their grid and reduce emissions from electricity production. And so as the grid gets cleaner, electric powered systems become cleaner as well. And also when they're combined with things like on-site clean energy. We'll talk through some different areas for electrification. A lot of it centers around heat pumps, but there are also other appliances, and in cases where you have multiple buildings in a close area, you can even look at district systems. When we're talking about building electrification, especially for existing buildings, a key part of that is electrical capacity and making sure that the existing electrical system has the capacity it needs to serve new electric loads like heat pumps and things. And, it may, like in some cases, it may require upgrade to or increase in capacity to be able to add those loads. At the same time, this is a reason in the path for decarbonization, we start by trying to reduce electric loads with, like lighting reductions and things like that, and also high performance envelopes that can help reduce heating and cooling loads and maybe lead to smaller sized equipment like heat pumps can help to have space and room in your electrical capacity. Heat pumps and for New York, really talking about cold climate heat pumps. There have been a lot of improvements and advances in heat pumps in the last several years, and there are several out there that are performing well for heating in cold climates, and those are specifically for air source heat pumps. But heat pumps are just a system that uses electricity to move heat from the outdoors or indoors, either out or in, depending. So in the heating or in the cooling season, you're moving heat from inside the building out, and in the heating season, you're moving heat from outside of the building in. And the various types, air source, water source, ground source, they all have different applications. Ground source are probably the most involved. You have to have wells that are, bored in the ground or, out over a large surface area. At the same time, they can work well with colder climates because groundwater temperatures stay pretty constant. We won't get into too much detail about each of these, but they each have their applications for a building, and with the advances that have been made in heat pumps, not just for cooling but for heating, make a really good option for space heating and cooling applications in a building. Heat pump water heaters, similar to the heat pumps for space conditioning, they're moving heat from one place to another to heat water, and are much more efficient than electric resistance water heaters or natural gas water heaters. One thing to keep in mind is a lot of heat pump water heaters do have larger or greater ventilation requirements than the electric or gas water heaters may have had, and so they may require more space. But you can combine them with storage tanks and other flexible controls that make them a very efficient way to generate hot water for a building, and they can be responsive to even electricity costs and things like that, and can help produce hot water more economically. Electric appliances, these are replacing what would be, normally gas-fired appliances, or could be gas-fired with electric, like induction cooktops. Heat pump dryers are another example for those. And if you have carbon-free loops, district loops, if you have especially like an urban area or a dense campus, they can be a good solution, where you are actually using some large scale ground source heat pumps to run like a district heating or cooling loop for multiple buildings. Now we'll talk about advanced controls that can support decarbonization, and really it's about turning things on and off and optimizing set points so that you are using less energy than the system would otherwise. Common areas, a lot of the controls are focused on load flexibility and being responsive to the grid, so that you can reduce the overall demand on the grid itself, and that can also help for an individual building with their operating costs. And then various forms of commissioning that become important with controls to make sure they operate correctly. So load flexibility and advanced controls, they can apply to hot water systems, HVAC systems, even appliances, things like that, lighting systems. looking at optimizing schedules. There are controls that can figure out how much time it's going to take on a given day to, heat up or cool down a building based on what the temperature is outside and based on data it's collected for, how long it's taken in the past. And then also being able to adjust temperatures, even pressures, and ventilation, things like that, to reduce the the energy demand and the electric load of your HVAC system during times when you may not have as many people in the building, or things are entirely unoccupied, things like that. And, another is demand response, and just, that gets to the grid interactivity and times when the grid has a lot of demand, maybe it can make adjustments even with adjusting temperature set points up by 1 or 2 degrees or down by 1 or 2 degrees to reduce the overall load on the grid. Commissioning, there are a few different forms of commissioning, commissioning of new systems to make sure that they operate as designed is becoming a more common practice, but something, especially, with existing buildings, you will find systems that either were not commissioned before, and so you can go through a retro commissioning process and go through and inspect the systems and components and then bring them back to operate the way they were originally designed. And some of that may be because they weren't commissioned originally. Recommissioning is, a system that was commissioned but maybe has been adjusted over time and is no longer operating the way it was designed, and coming back in and essentially recalibrating it and bringing it back to operate the way it was designed to. And last, there's monitoring-based commissioning, which is really just an ongoing process of commissioning to make sure that the systems continue to maintain their optimal operation. And last, moving to distributed energy resources, small scale power generation and storage on site for buildings that, in many cases can provide some more resilience and flexibility for your building, and also clean power sources for your building. Renewable energy is a very common one, and solar PV is probably the most common. They can be located on site for a building and provide a clean energy source for operating your electric systems. You can combine those with battery energy storage, and that helps to add flexibility, like we talked about, with a PV system that may produce more energy than you need during the daytime. You can store some of that in batteries, and then you can use that at a time when the PV system is not producing as much. Same with wind. If there's like a high wind time, you can store power and save it to use later when there's a period with less wind. And now with the prevalence of electric vehicles, they add another layer in this process, and can actually be used like a battery energy storage system when you implement bidirectional charging. And all that means is that, when you can charge the electric vehicle when it needs it, but when there are times that the electric vehicle is sitting there, say it's fully charged, it's not needed, you could actually draw power from the vehicle to power the building. And there are control systems to help manage that. But if you had a fleet of electric vehicles, they could actually, in effect, be a battery energy storage system for your building using bidirectional charging. And last, thermal storage, and this is similar to battery storage, but instead of storing electricity, you're storing heating or cooling energy. And there are various forms of it that use chilled water, that use ice, that use other different materials. But it's a way for you to capture excess heat or cooling and store it for use later. So if you had a system that produced a lot of heat, and you wanted to capture some for use later, we talked about the energy recovery systems. Like maybe you even have more than you could use to condition incoming air or water. You might be able to capture it with a thermal energy storage system. It also, provides a way to shift demand where, you might use mechanical equipment to charge up a thermal storage system and then use that for heating or cooling during times when the electricity demand is higher, and you can run, like one or two small pumps instead of a whole chiller or a whole boiler or something like that. Here we have a slide with just some helpful cost ranges for estimating costs for decarbonization strategies. And these are here to help when planning a project and starting to estimate what your costs might be to incorporate decarbonization. Looking at added costs for building envelope improvements or installing heat pumps of different types, right? Air source versus ground source, things like that. Also adding photovoltaic systems or electrical vehicle charging, and what those costs can be for a building and for a project. It also at the bottom includes items for infrastructure upgrades. We talked about electrical upgrades for an existing building where you might need to upgrade the capacity for adding in things like heat pumps or other equipment, as well as if you are adding heat pumps in an existing building, you're probably going to have to run electrical wiring and things like that that may not have been in place, and provides estimates for each of those that can be helpful in the planning process. And now we'll move to talk about the DRI and NYF programs in particular, and compliance decarbonization requirements for those programs. Within the programs, the threshold for meeting decarbonization requirements is 5,000 square feet. And that's really looking at those programs can be new buildings, substantial renovations, building additions. And so any building that's over 5,000 square feet, whether it's new, a building addition, or a substantial renovation, is going to be required to meet decarbonization paths. For buildings that either are under 5,000 square feet or in a renovation scenario don't meet the definition of a substantial renovation, then they can still opt in to a compliance path for decarbonization, even though they're not required. And we would encourage that for them as part of helping the state meet their goals for reducing greenhouse gas emissions statewide. Compliance path options for decarbonization within the DRI and NYF programs. There are three paths. The first being meeting the New York Stretch Code. The New York Stretch Code is above and beyond the base energy code for the state and is approximately 10% more energy efficient than the base energy code. It can be met through prescriptive means or a performance-based path. The prescriptive approach for New York Stretch Code means that you're meeting specific criteria for different elements of the building, like building envelope, insulation levels, building lighting, efficiency of systems and equipment, being compatible for renewable energy or electric vehicles, things of that nature. The performance-based path is intended for buildings that want to meet the stretch code, but that for one reason or another may not meet a specific prescriptive requirement, even though they have a really high performing building. And this path allows to demonstrate you're meeting the code through a whole building energy model and demonstrating that your energy use intensity and energy performance of your building is at or better than the New York stretch code. The second compliance path option is through Energy Star and achieving an Energy Star score of 90 or better. The Energy Star program helps determine building energy performance relative to other buildings of similar type and in your region, your area. So it's kind of how you stack up against other buildings like yours. And this compliance path is met using a software tool called EPA Target Finder that is a free tool available. It requires projecting your building's energy use and energy performance. So likely a building energy model, and then some other basic building information, and it will you can enter that in and it will generate an Energy Star score or projected score for your building based on how you projected it operating and using energy. The third path is through third-party certifications. And there are a variety out there. We've listed several here. LEED is a very common one. WELL is becoming more common also. There are other ones like Passive House, but they are operated by other certification entities, and by meeting those requirements and to achieve certification through those programs, that is a means for demonstrating decarbonization within the DRI and NYF programs. And finally, for people in the webinar that are either in communities that are part of DRI and NYF, or maybe thinking of applying to future rounds of it, how do you decide which path, what makes the most sense? For the New York stretch path, this is a good path for situations where you have partial upgrades. In the case of the prescriptive path, compliance is required for those components that you're retrofitting or upgrading. So if you're only doing a partial upgrade, you only have to meet the prescriptive path of the stretch code for the things you're upgrading. You're not going to be held to the entire code for the whole building. That can be especially helpful with historic buildings that may have limitations on what they can do with especially the building envelope. Also, if you have a building that's an older building and you just have high energy use compared to others like yours, we already talked about that's sort of how the Energy Star score works. So that may not be a good option, but the stretch code may still be good. Or if you are in a jurisdiction that requires the stretch code, it would make a lot of sense to choose that path if you're going to be held to it by the local code anyway. Things to think about is that these requirements are more stringent than the state's base energy code, so you are going to be going above and beyond that. And if you're choosing the performance path, then you're also going to need to be doing energy modeling for your building, and that you may need to bring in a consultant for that. For the Energy Star path, this is good for buildings that know they're high performing and that they would score well against their peer buildings. If you're familiar with Portfolio Manager and the Energy Star and EPA systems, it can make a lot of sense. Also, if you're already planning to do an energy model, so you could easily have your projected energy use, that can make a lot of sense to follow this path. If you weren't, then obviously that's a consideration that you'd be doing some simulation or energy modeling in order to project a score or an Energy Star score for this. For the third path with third-party certifications, obviously it's good if you're already considering it, or if it's something where you think it would help distinguish your project within the community, and make it more marketable to tenants or occupants. things to think about are just added costs for registration. You know, all of the programs have some form of registration fee, may even require licensed professionals or additional inspections that are beyond, you know, local code requirements, things like that. So there may be additional costs to follow a third-party certification path. And with that, I will open for questions. Thank you everyone for listening, and we'll take questions from folks here for the next, I guess that's probably 15 minutes.
Thanks so much, Michael. If you have a question, I request that you submit it through the chat, and then I'll read them aloud and just say thanks to the people that have already submitted a few. So we'll go ahead and start with those. So the first question we got is, with the goal of decarbonization being anchored on making HVAC to go on electric, is there any study that showed that the utility power system can handle this target of 85% reduction by 2050, bearing in mind the quest for EVs?
That is a good question. I don't know offhand of a study. I mean, I would say that NYSERDA likely, you know, has evaluated that, and I know for a lot of not just New York but other locations, you know, that's a part of the conversation for decarbonization and electrification, are grid capacity, not just building capacity. You know, but I think that's in talking about a decarbonization path, that's part of talking about looking at load reduction and efficiency strategies to help bring down other loads in a building, so that as you move toward things like heat pumps that are, you know, maybe replacing a fossil fuel system with an electric system, that you've reduced other electric loads in the building so that your net change is minimal. And, you know, so that's a key part of the overall strategy, not just for an individual building, but at a, you know, grid scale, that by reducing other loads and other demands, you can still achieve electrification without needing to significantly increase your grid capacity.
Another question we received is it really possible to control systems to take advantage of the varying cost of electricity during the seasonal cycle, and at what scale?
There are a lot of systems out there that have, I would say, have progressed significantly in the last probably 5 years at, you know, being able to control various systems. I don't know that there's necessarily one out there that just like you put one system and it can take all of it and handle it all. There's ones that's, you know, end up being kind of specialized for different components, you know, maybe more appliance focused, more HVAC focused, things like that. I was reading a study yesterday of a company in Hawaii that was implementing software technology to that was focused specifically on water heaters, domestic water heaters, and making them more grid responsive, you know, to like the minute kind of thing. So, you know, there are advances that are being made. Like I said, I don't know that there's necessarily one system that you could just like install that and it'll cover all the pieces of your building. But as software advances, as technology advances, and also as more data is available from the grid, you know, that has become a key component that is moving that forward. And, you know, I think in another, you know, couple, like 5 years time, you'll probably see some systems that really can handle the amount of data coming in and also control, like, you know, the multiple systems within a building to be responsive in that way.
Thanks. All right, next question is, are there any specific recommendations to cite battery storage? This person also notes, based on recent conversations with the industry, there are some issues with cooling fan noise similar to cryptocurrency.
Me personally, I don't necessarily have any. I can't say I'm an expert in battery storage. I'm sure that there are some consultants out there who have, you know, higher specialization in that that could help with siting and just general siting advice. Yeah, at the same time, I'm sure it's very specific to different projects in terms of what kind of space you would have. Obviously, if you're building a new building, you can design for it and even put in, you know, acoustic buffers and things like that for noise. But if you're in an existing building, it becomes more challenging. And I wish I had a better answer for you of, oh yes, do this and it'll solve it. But I'd say, you know, consulting someone that's got more direct experience on battery storage systems would be my best advice.
Another question, can an electric vehicle owner contract with the grid system to allow the battery to be used as a buffer, perhaps in return for keeping the vehicle charged for no cost to the owner?
That's a really good idea. I don't know. That's the question for a utility for sure. And you know, just like we see with PV systems, you know, the rules for PV systems vary from one utility to another, you know, whether they allow you to feed energy back to the grid or not, and you know how that gets billed and things like that. You know, so I think that's an excellent idea that, you know, would be something for a local utility to consider, but I don't think that there's any kind of blanket regulation that would allow that.
And then I think the last one is we just have a comment from somebody that we would like our town planning board to be promoting these considerations for projects as they come before the board. Do you have any advice? I think this is for non-DRI and New York Forward projects too, potentially.
Yeah. I think that, you know, we had the slide earlier near the beginning talking about benefits of decarbonization. And, you know, that's a key piece to communicate to folks and, you know, doing some just education around, you know, the what and the why. I think decarbonization, I don't know if it can be a loaded term, but I think it's one that certain, you know, different people may already have an idea of what that means. And while, you know, we talked about the definition of electrification, and that's clearly a big part, that's not like the only way to do decarbonization. And I think sometimes everyone thinks, oh, that means just all electric everything. But, you know, doing some education and focusing on the benefits and you know, also the fact that, and it wasn't necessarily listed in the benefits there, but, you know, it can also lead to reduced operating costs for buildings. You know, if you're able to integrate on-site sources to offset costs from the grid and things like that, they can help in your operating costs for a building, and, you know, improving efficiency of pieces of equipment inherently means that you're using less energy, which not always, but typically means spending less money on it to get the same result. You know, and so communicating those benefits to projects, I think, will encourage folks to look into decarbonization further and see it as something that's not a burden, but a benefit to them and their project.
I think that pretty much covers it for the questions that we have. I just want to thank everyone again for attending today's webinar, and we'll be posting the recording and the slide deck on the capacity building component of the New York Forward website, so be on the lookout for that. And again, we have future webinars coming up that you'll receive notification of, similar to this one. And again, just thank you, and thank you again, Michael, for all this great information. And have a good afternoon, everyone. Bye.
Thank you, everyone.